Okay, let's take a look at question 11, sample exam 1 in Chem 11. This one gives you a few statements, and then wanting to know which one is the true statement. So let's take a look here. So the first statement is the nucleus is less dense than the atom. Nucleus is in the middle, the atom is then the whole thing, right? Including the nucleus. And remember, in the nucleus, you're packing a lot of subatomic particles, which is your protons and your neutrons. So the mass of these guys, right, is way greater than the mass of the electron, which is sort of distributed randomly around here. So if you consider the mass of the proton and neutron packed into a very small space, and then basically the mass of that same mass, but then packed into a much larger space, of course that means that the density of the nucleus is very high, and so the nucleus is way more dense than the atom. So that first one would be wrong. Second one, nomenclature question, BaNO3 is barium-2 nitrate. There's actually a mistake here in the question, so that should say BaNO3 2, but then remember that barium, if you look at the periodic table, is in group 2, and group 2 doesn't require the Roman numeral to give it a name, so that's also wrong. Now the third one is a question about limiting reactant. It says that you have a reaction that looks like that, and then you react 4 moles of A, 2 moles of B. Limiting reactant is A. Okay, remember that if you want to figure out limiting reactant is by taking the number of moles and dividing by coefficient. So in this case for A, it would take 4 moles of A and just divide it by the 3 moles of A needed per reaction. And then for B, I'll take 2 moles of B divided by 1 mole of B needed per reaction. Here I got 1.3 roughly reaction. This one I got 2 reaction. So that gives me a smaller number. Smaller number means limiting reactant is A. Okay, so that one is correct. Then let's look at number 4. It says, according to the law of definite proportion, and what that law says is that the percent of element in a compound is the same for compounds from different sources. So in this case, it says 2.5 grams of compound is decomposed to yield 1.83 grams of oxygen and 0.67 grams of carbon. Then it says if you decompose 4.7 grams of that compound, it should give you 1.3 grams of oxygen. So what we need to think about is just what is the percent oxygen here in this compound. So the percent oxygen is going to be 1.83 grams. That's from this number right here, divided by the original first sample of the compound, which is 2.50. You get 73.2%. Okay? Then if you look at the second sample there, it says you decompose 4.7 grams, you should get 1.3. So the question then is 1.3 out of 4.7 also 73.2? And if you do that calculation, that's only 27.7%. So it's way different than that actual number. So that means that the fourth one is also wrong. So the only one that's correct is number 3. So that means that our answer is E right here.